I'm Sandy Cowan. I'm the Grease Technology Manager for Citgo Petroleum, and I'm here in the Mystik Grease Lab to talk about polymers. So what's a polymer? Why do we use polymers in grease? Well, the word poly means many. Mer refers to repeating segments. So a polymer is a series of many repeating segments that are hydrocarbons. So why would we want to use a polymer in grease? Well, one thing that you want for grease is you want the grease to stay in place. Polymers help a grease to do that. They're very adhesive. If you have an application with intermittent usage, for example, it sets overnight and it's used again the next day, you want grease to be in the contact zone when the equipment starts operating. Otherwise, there's some wear that can take place before the grease can reach the contact zone. Polymers also lower the oil separation. You certainly don't want all the oil to separate from the thickener. And if there's a problem with that, the use of polymers can improve that. Polymers come in many different types. Polymers can be a very dry, hard material, and that's dissolved into the grease. Or you can have a polymer that's more fluid and more stringy. Polymers can impart different characteristics, different textures. Some make a grease very tacky. Some can actually impart some benefits without changing the texture of the grease much at all. Polymers also improve the VI of the grease. VI stands for Viscosity Index. So greases have different flow characteristics. They can flow very easy, they can have more resistance to flow. Raising the viscosity index makes the viscosity more consistent as the temperature changes. So there are some cases in which you want the viscosity to remain the same by incorporating some polymer into the grease. So how does that work? How does the addition of a polymer actually make the consistency, the viscosity more consistent? Well, polymers are segments that can coil and become very large, or they can compress. At cold temperatures, polymer structures, these long hydrocarbons with repeating chains, get very compressed. So if this room is a bearing and we're the grease, if it's very cold, the polymers are compressed. It's not just one, there are many hundreds of thousands, but they're all compressed. So the impact on the viscosity, yes, it will raise the viscosity, but the impact is less than when it's hot. What happens to a polymer when it gets hot? Well, the answer is they expand. They get extremely large and they may be very coiled. So they're taking up not a small space now in the oil, they can take up a very large space. And as they expand, and thousands of these are expanding, the impact on the viscosity as it gets hot is they thicken the oil. So as the oil would naturally become less viscous as it heats up, the polymers then expand, and in expanding, they increase the viscosity, thus countering the reduction in viscosity that you see in the oil itself. To learn more about polymers and our Mystik greases, please look to mystiklubes.com and check out our resource center.